Okay, this is the first podcast on the reactions unit. We're going to be looking at the different types of reactions, many of which we've talked about before, but we're going to classify them and talk a little bit more about what happens during them. Okay, so let's go ahead and get started. All right, so let's just remember what are some of the changes that we identify as indicating that we have a chemical change going on. Well, as you remember, an obvious one is if a color changes, that means we have a new product that's formed and it's a different color than the reactants were. So in all cases, we're looking for some indication that something new was formed. We could form a precipitate, which means we have a solid or something that actually looks cloudy when I mix two solutions together. I can form a gas, and what I'll actually see there is I'll see bubbles, especially if I have it's in a liquid. And the last one is a change in temperature is usually an indication that you have a chemical reaction going on, although sometimes that can be a physical change. Okay, so the law of conservation of mass is important for us too because it says matter can't be created or destroyed. And where that's important for us in balanced chemical equations is it tells us that the number and type of atoms that are present before a reaction occurs are the same number and type after a reaction occurs, which is why we can do the balancing that we do with chemical equations. We know that the atoms have to go somewhere. Okay. So let's take a look at writing an equation, a chemical equation from words, right? We've done this before, and actually some of these are the same things we've done. So let's just start. We have aluminum metal, so it's aluminum solid. It reacts with aqueous copper 2 chloride. So copper is a +2, chloride's a -1, so it's CuCl2, and I gave it the AQ symbol. And I use a catalyst. Now, anything that's not involved in actually reacting is usually written over the arrow. And you may have heard this in middle school, but a catalyst is something that you add to a reaction to speed it up, but it doesn't get consumed. So we're really not changing the catalyst, so we're going to put it over the arrow. And when we do that, we make copper solid and aqueous aluminum chloride. So aluminum chloride is going to be AlCl3. Now I need to see whether or not, and that should be labeled as aqueous, which I forgot to do when I wrote this, but this should be AQ. And then I go back and I balance it, and when I'm done, I can say voila. All right, let's look at one when we go the other way. Here we want to write the word equation. So let's just start. So I have magnesium solid, or magnesium metal, reacts with water. When heated, this symbol, the change symbol, indicates heat. Okay? And again, it's something that's involved in helping the reaction, but it's not consumed. So we put it over the arrow. Reacts with water when heated to produce magnesium hydroxide solid and hydrogen gas. Now, those aren't the exact words you need to use, but you get the idea. I mean, I could say hydrogen gas was evolved, or I could say magnesium hydroxide solid. Okay. So let's do just two that are on page 3 that are there for practice. Okay, so when a solution of hydrogen chloride is added to solid sodium bicarbonate, the products are carbon dioxide, water, and aqueous sodium chloride. So let's see what we know. So we're starting with a solution of aqueous chloride. Of hydrogen chloride. So when we are told we have a solution, we generally can assume it's aqueous unless we're told otherwise. Okay, and when it's added to solid sodium bicarbonate, so this should have an S here, we get the products are carbon dioxide, water, and aqueous sodium chloride. So that's our equation. And if you do some inspection, you'll see that it's all balanced. And I can say voila, and try the next one. All right, number 2 says steam, which of course is gaseous water, reacts with carbon at high temperatures to produce carbon monoxide and hydrogen gases. So I have water in the gaseous state plus carbon in the solid state, and they are going to react at high temperatures. So I put the heat symbol over the arrow to produce carbon monoxide gas and hydrogen gas. And remember, hydrogen is diatomic, so we have to show it as H2. If I look at this, I inspect it, I see that it is balanced already. Okay, so we're going to stop right there.